In question number 1, it is given that the radius of circumcircle of a right angle triangle is 10 centimeter and the altitude drawn to the hypotenuse is 8 centimeter. What is the area of the triangle? I have already drawn the diagram. So here, what is circumcircle? Circumcircle is a circle that is drawn outside of a triangle. So here, this is a circle of with center O, and ABC is a right angle triangle. So here OB is the altitude drawn to the hypotenuse of length 8 centimeter and OC is the radius of 10 centimeter length. So here given that radius of circumcircle of right angle triangle 10 centimeter, right? So since this is right angle triangle, we can say also OC is the radius, right? So here we can see that O is another radius, correct? Because center situated at the midpoint of the hypotenuse. If OC is the hypotenuse and AC is the diameter, that means O situated at the midpoint of the hypotenuse. So therefore, OA equals to OC, that is 10 centimeters. So we can easily find the length of the hypotenuse, that is twice of radius, hypotenuse AC, 2 multiplied by 10 centimeter, 20 centimeter, correct? Now, the altitude drawn to the hypotenuse, that is already been given. OB equals to 8 centimeter. Now remember the formula for finding area of a triangle, the general formula. That formula is half into base into height. So here if we consider base as AC, then the height will be OB, right? So here area of the right angled triangle half into AC multiplied by OB. Let's put all those values. 20 multiplied by 8, 80 centimeter square is the area. Hence, area of the triangle is 80 centimeter square. Option B is the correct answer. In question number 2, it is given that two circles touch externally. I have already drawn the diagram. Here is the two circle of center having centers C1 and C2 respectively. They touch each other externally. The sum of their areas is 41 pi square centimeter square. If the distance between their centers is 9 centimeter, then what is the difference between their diameters? So look here, first I can write, let the center of the two circles be C1 and C2, okay? And the distance between their centers is 9 centimeter, then C1, C2, 9 centimeter. Okay, so here R1 and R2 denotes the radius. R1 and R2 denotes the radius. Okay, so we can write also it's been given the sum of their areas 41 pi centimeter square. Okay, so what is the formula of area of a circle? That is pi r square, where r is the radius. So we can use it, pi r1 square plus pi r2 square equals to 41 pi. That means r1 square plus r2 square 41. Okay, so equation number 1. Also, the distance of their centers, that is 9 centimeter. So R1, since they touch externally, that means R1 plus R2 equals to 9. Name it equation number 2. Now from here also I can write R2 equals to 9 minus R1. Now let's put the value of R2 in equation number 1. Put the value of R2 in 1. We get, so here R1 square plus, it will be 9 minus R1 square. Make the correction, 9 minus R1 whole square equals to 41. R1 square plus 81. We already know the formula of expansion of a minus b whole square, that is a square minus 2ab plus b square minus 18 R1 plus R1 square 41. Let's proceed with the steps. So here plus 40. Now we can easily take common 2, 20. So further we will factorize it by middle term method. So we got here 4R1 plus 20 equals to 0. Equals to 0. So either from here I can write either R1 minus 5 equals to 0 or R1 minus 4 equals to 0. That means R1 equals to 5 or R1 equals to 4. So if R1 equals to 5, then R2 equals to 4 centimeter, or for R1 equals to 4, R2 equals to 5 centimeter. Correct? Now, what we are required to find the difference, their diameters. Okay, so here for R1 5 centimeter, R2 4 centimeter, diameter 10 centimeter and diameter 8 centimeter. Therefore, D1 minus D2 2 centimeters. Similarly, we can check so here D2 now the difference is again 2 centimeter. So no, both the cases we are getting the difference 2 centimeter. The difference between the diameters is 2 centimeter. This is the answer then. So here option C is the answer. In question number 3, it is given that let P be the area of the square X and Q be the area of the square formed on the diagonal of the square X. What is the value of P by Q? So here ABCD is the square of area P. Okay, that is square X. So let length of the side of the square X be a unit. We can assume the length of the edge as a unit. Okay, so what will be the area then? A square. Therefore P equals to A square unit. Let's name it equation number 1. Now, how can we find the diagonal of the square x? There is a formula. The formula is root 2a. This is the formula. Okay. So here the length of the side of the bigger square since one of the side is the diagonal of the smaller square, so that is the length of diagonal of square x, right? So I have already told you how to find the diagonal, that is root 2a. So here root 2a unit. Okay. Therefore, and also q be the area of the bigger square. So we can write q equals to root 2a whole square. That means 2a square. Let's name it equation number 2. Now we can find the value for p by q, a square by. Question number 4, it is given that the minute hand of a clock is 21 centimeter long. What is the area on the face of the clock described by the minute hand between 10:10 am and 10:30 am? Here the clock is of circular shape and the radius of the circle is 21 centimeter. Okay. Now when the clock, the minute hand moves from 10 minutes to 30 minutes, it makes theta angle at the center. Now we know for the minute hand to round entire clock, it takes 60 minutes. That means in 60 minutes, it makes 360-degree angle at the center. So for 20 minutes, because the time duration between 10:10 am and 10:30 am is 20 minutes. 10:30 am to 10:10 am time duration is 20 minutes. Within this 20 minutes, the minute hand will make uncentral angle theta, that is central angle theta, that is 20 by 60 multiplied by 360 degree. So it would give us the value 120 degree. So this minute hand would make 120 degree angle at the center. Okay, next, as I have already drawn the figure, so we can easily see that there is a sector formed in between this portion. Okay, so what is the formula for finding area of a sector of a circle? Let me first write the formula. Area of sector of a circle, that is theta by 360 degree multiplied by pi r square. So here r is 21 centimeter. So we will put all these values to get the area of this portion. So here, therefore, area, we know the value for theta 120 degree multiplied by pi 22 by 7. We will take pi, the value of pi as 22 by 7, and r 21 square. 377. It would give us the value 462 centimeter square. Okay, so option C is the correct answer, 462 centimeter square. In question number 5, it is given that the area of a rhombus is 336 square centimeter. If the length of one of its diagonals is 48 centimeter, then what is the perimeter of the rhombus? I have already drawn a figure of a rhombus. Here ABCD is the rhombus where AC and BD, these two diagonals, and they meet at the point O. We know that the diagonals of the rhombus perpendicularly bisect each other. Okay, so here area is given as 336 centimeter square. Also one diagonal, let's say D1 is given as 48 centimeter. Now, what is the formula for finding area of a rhombus? The area of rhombus, that is half into product of the diagonals. Let's say D1 multiplied by D2, where D1 and D2 are the length of the diagonals. Okay, so here, therefore, we can find D2 equals to 336 multiplied by 2 by 48. That will give us the value 14 centimeter. 14 centimeter. So next, we now can say that since they bisect each other at right angle, so let's say here this one is 7 and this one is 24. Okay, so we know diagonals of rhombus bisect each other at right angles. Okay, so therefore we got BO 7 centimeter, and let's say we can say OC as 24 centimeter. Now look here, this here BOC is 90 degree. That means triangle BOC is a right angle triangle, right? So in BOC, it will we can apply Pythagoras theorem. So where BC equals to root under OB square 7 square plus 24 whole square. According to Pythagoras theorem, we can write this. This will give us the value 25 centimeter. This is the length of a side of the rhombus. So therefore, length 25 centimeter. So the perimeter of the rhombus, we know the formula for perimeter, that is 4a, where a is the length of one side. 4 multiplied by 25 centimeter, 100 centimeter. Let me check the answers. Here option C is the correct answer. In question number 6, it is given that the length and breadth of a room are 21 meter and 16 meter respectively. If the length of the longest rod that can be placed in the room is 29 meter, then what is the height of the room? Okay, so given the length of the room, that is 21 meter, breadth 16 meter, right? And the length of the longest rod that can be placed in the room diagonally, in the room, okay, not diagonally, in the room, that is 29 meter. Yes, now what did I mention diagonally? Because we know that the length of the longest rod that can be placed in a room is the diagonal of the room. So we know the length of the longest rod that can be placed in the room is the diagonal of the room. So the formula for finding diagonal of a room, since the room is of cuboid, because we can see length, breadth, and length, breadth are different dimensions. So the room is of cuboid. So we know the formula for finding diagonal of a cuboid. Diagonal of a cuboid. The formula is root under length square, breadth square plus height square. Here height is not mentioned. We are going to find it. Therefore 29 equals to, we can assume the height as h. So 16 whole square plus h square. So h square equals to 841 minus 441 minus 256. This would give us the value 144. 8 square equals to 144, or h equals to 12. Therefore, height of the room is 12 centimeter. Option C is the correct answer. Okay, it's not centimeter, sorry, it's meter. Let me change it here. 12 meter. In question number 7, it is given that a hemispherical bowl of internal radius 18 centimeter contains a liquid. The liquid is filled in small cylindrical bottles of internal radius 3 centimeter and height, internal height 4 centimeter. What is the number of bottles used to empty the bowl? So given that internal radius of hemispherical bowl, so we can assume it as R1, 18 centimeter. Also internal radius of cylindrical bottle, let's say R2, that is of 3 centimeter, and internal height of cylindrical bottle, let's say H1, 4 centimeter. Okay, now we can assume n number of bottles are used to empty the bowl. Let n number of bottles are used to empty the bowl, right? Now, so that bowl will be completely empty, right? That means the volume of n number of cylindrical bottles will be equals to volume of hemispherical bowl. Therefore, n number of bottles, okay, volume of n number of bottles equals to volume of bowl. Now, what is the volume of one cylinder? That is 1/3. Okay, not 1/3, pi r square inch. Pi r square inch. And here the volume is 2/3 pi r cube. So we are going to use the formula. In volume of n bottles will be n multiplied by pi, here r3 r2 square h1, and volume of bowl 2/3 pi r1 cube. Let's put all those values for r1, r2 and h1. R2 for 3 whole square and 4, 2 by 3 pi, here 18 whole cube. Both the pi got cancelled here. So n equals to 2 multiplied by 18, 3 and 4, 6, 2, 4, 6. So the value of n is 108. We know 18 multiplied by 6, 108. Hence 108 bottles are used to empty the bowl. Here option C is the correct answer. In question number 8, it is given that a hollow spherical shell is made of a metal of density 7 gram by centimeter cube. If its internal and external radius are 3 centimeter and 6 centimeter respectively, then what is the mass of the cell? So it's given here that density of the metal is 7 gram per centimeter cube, correct? So that means, and also it is given the internal radius and external radius. We can refer it as internal radius are 3 centimeter and external radius as 6 centimeter. Now, there are two formulas we are going to use. One is volume of hollow spherical shell. So the formula is volume of hollow spherical shell. 4/3, since this is hollow, so the volume will be pi r cube minus small r cube. Let's put the values first. Next, we will use 22 by 7 in place of pi. Here r cube, 6 whole cube minus 3 whole cube. So this will give us the value 27, 189, 88 by 21, 9 and 792 centimeter cube. Now, what is the relation between mass, density and volume? The relation is mass equals to density, the product of density and volume. So here density is given 7 gram per centimeter cube and volume 792 centimeter cube. So mass will be this much. Question number 9 states that a cone of height 16 centimeter and diameter 14 centimeter is mounted on a hemisphere of same diameter. What is the volume of the solid thus formed? Take pi equals to 22 by 7. I have already drawn the figure. There is a cone on the top of a hemisphere. Okay, so here given that the height of the cone height of the cone, if we denote it as h, that is given as 16 centimeter. And diameter of the cone, we can name it as let's say 2r. If r is the radius, that is 14 centimeter. Therefore, radius of the cone we can say 7 centimeter. Okay, so here this is the radius. Since this is mounted on a hemisphere, so the cone and the hemisphere both are having the same radius. Okay, so we can write, therefore, radius of hemisphere, that is also 7 centimeter. Okay, volume of the solid thus formed. So volume of the solid. So what will we do? We will first find the volume for the cone and for the hemispheres individually. Then we will add them out to get the total volume of the solid formed. Okay, so what is the formula for cone finding volume? That is 1/3 pi r square h. And the formula for finding volume of a hemisphere, that is 2/3 pi r cube. These are the formulas we are going to use. So the volume of the solid will be 1/3 pi r square h plus 2/3 pi r cube. Okay, so here now we will put all the values in the place of r and h and get the final answer. So 1/3 we will place pi by 2, 22 by 7 in the place of pi. 22 by 7, 7 whole square and 16 plus 2/3, 22 by 7, 7 whole cube. Okay, now we can further simplify it. Look, here we can take common 22 by 7, 1/3 and 7 square also. So let's take out all the common terms. So here we will left with 16 plus 22 by 7, 7 square and by 3, so 14. It becomes 30. It becomes 30. So 10, the answer is 1540 centimeter cube. This is the answer. Okay, so here option A is the correct answer. What is the volume of the solid? 1540 centimeter cube. In question number 10, it is given that 3 cubes, each of volume 343 centimeter cube, are joined end to end. What is the total surface area of resulting cube? Now look here, I have already drawn the figure. There are 3 cubes, each of volume 343 centimeter cube, and they are joined. When they are joined, it becomes, look, it becomes a shape of cuboid. Yes, cuboid. It's not a cube anymore. Look, so here it is given that volume of each cube 343 centimeter cube. Okay, now we can assume that the length of one edge of each cube be a unit, right? So all the sides, length of all the sides of a cube will be a unit, correct? Now when they are joined, it becomes cuboid. So in that time, the length of the cuboid will be what? Look, a plus a plus a, it will be 3a unit, correct? You can see from this figure also. And the height, okay, this will be the length, and the height will be only a unit. Height is same. And what about the breadth? That is also a unit. Okay, so when the cubes when the cubes are joined end to end, length of resulting cuboid will be 3a unit. Okay, and this is the height and this is the breadth. So these are the dimensions for resulting cuboid. Okay, now what is the formula for finding total surface area of a cuboid? Now let's write it down first. Total surface area of cuboid, the formula is 2 into LB plus BH plus LH. Correct? Now we will put all these values of LBH in this formula. So therefore, total surface area, in short, we can write TSA a square 3a square. Okay, so it will become 7a square, that is 14a square square unit. Let's name it equation number 1, right? Now remember, this cuboid is formed using 3 cubes and we know the volume of each cube is 343. Correct? So volume, what will be the volume for the cuboid? Volume for the cuboid will be the total volume of these 3 cubes, right? So here, therefore, volume of cuboid, that is equals to 3 multiplied by volume of each cube. Correct? Now, what is the formula for volume? Okay, the formula for finding a volume of cuboid, that is L multiplied by, this is V for volume, L multiplied by B multiplied by H, cube unit. Okay, so we can write here 3 multiplied by volume of each cube. If A is the length of one inch, so the volume of a cube will be A cube. Okay, so here let's put all these values of LBH in terms of A, that is 3A, 3, and already we know the volume value for A cube, that is 343. Now let's solve it. It will be 7. So here A is 7 centimeter. Now we will put the value of A in equation number 1. Seven in 1, we get total surface area 14 A square, 686 centimeter square. So 686 centimeter square. Option C is the correct answer. In question number 11, it is given that a cubical block of side 14 centimeter is surmounted by a hemisphere of radius 7 centimeter. What is the total surface area of the solid thus formed? Take pi equals to 22 by 7. So look here, I have already drawn a cubical block and at the top of it, there is a hemisphere. Okay, so let's say, okay, so the edge is 14 centimeter, edge of each side of the cubical block. Now, so it is given that length of each side of cubical block equals to 14 centimeter. Okay, and the radius of the hemisphere, this is the radius is 7 centimeter. Radius of hemisphere, that is 7 centimeter. Now, how can we calculate total surface area of the solid? Look here. What are the how many total surface are there in cubical block? There are 6 total surface, correct? So here there are 5 surfaces intact, no issue with that. But what about the top surface of the cubical block? There is a hemisphere. So the portion that is hemisphere located on the top, so that portion of the surface of the cubical block and the base surface of the hemisphere, both are same, both are overlapping. So when we will calculate the total surface of the solid, what we will calculate? So total surface area of the solid, that will be, first of all, total surface area of the curved surface area of the hemisphere, total surface area of hemisphere, no, not hemisphere, of cubical, I mean cubical block of cube, okay, plus curved surface area of the hemisphere, surface area of hemisphere. Now look, here we have already taken total surface area, right? That means already this portion, that the common surface area for the hemisphere base and the cubical block, that is already been calculated once, okay? Next, so here so next we will multiply from it that the base area, circular base area of the hemisphere, because that is that is overlapping due to the hemispherical term. So here we will subtract circular, sorry, I should write here circular base area of hemisphere. Why? Because you can see if there is a hemispherical term, so this portion will covered by the hemisphere. Only we can see the open area, right? So that's why we have to remove this much portion. So the total surface area for a cube, the formula is, the total surface area for a cube, the formula is 6a squared, where a is the length of one edge. Okay, so here a is 14 centimeter plus circular curved surface area of a hemisphere, that formula is 2 pi r square, where r is the radius. So 2 pi r 7 whole square minus circular base pi r square, pi 7 whole square. So it will give me 7/6 plus 1330 In question number 12, it is given that how many silver coins 3.5 centimeter in diameter and of thickness 4 millimeter must be melted to form a cuboid of dimensions 21 centimeter by 11 centimeter by 7 centimeter. Okay, so here silver coins. First of all, silver coins are of cylindrical shape. Okay, so here given diameter in centimeter and thickness in millimeter. So we have to convert any one of them into the same unit. So here given diameter of silver coins, that is of cylindrical shape, thickness 4 millimeter, we can convert it into centimeter. To do so, we have to divide with 10. It will become 0.4 centimeter. Diameter is given as 3.5 centimeter. Okay, these are the dimensions for silver coins. Silver coins. Fine. Now, dimensions of cuboid. So, okay, one more thing. Let's find radius also. Radius, that will be 3.5 by 2. So it will be 1.75 centimeter, right? Next, dimensions of cuboid, that is already being given. Length 21 centimeter, breadth 11 centimeter, and height, that is 7 centimeter. Now we can assume let n number of coins are melted to form a cuboid. Let n number of coins are melted to form a cuboid. Okay, so what will happen? The volume of this total number of coins, that is in number of coins, since we will use that portion of metal, that quantity of metal which we'll get after melting all the coins, we will use that metal to form a cuboid. So that means in such case volume will remain same, right? So volume of in coins, therefore volume of in coins, that is equals to the volume of cuboid. So here in multiplied by, since silver coins are of cylindrical shape, we know the formula for finding volume of a cylinder, that is pi r square h. Pi r square, let's say r square r1 square h1. Okay, and here volume of a cuboid, so L B, let's say h2. Now put all the values here. So in multiplied by r for coin 1.75 whole square, and thickness is the height, thickness is 0.4. Also here 21, 11, 7. Now let's do the calculation. One 1.75 and 0.4. Fine. Now look, we can further simplify it. So if we simplify it, we will get now 1.75. If we convert into fraction, we will get 7 by 4. This will become 2. 7 by 4. If we convert 1.75, we will get 7 by 4. and 4 by 10. How? If you want to make me show it, how? I can show it 175 by 100. Now let's divide it with 25. With 4 here and 7. So that's how it becomes 7 by 4. Okay. So both the 7 got cancelled. Okay. Next, we will get 1, 4 will get cancelled here. Okay. So it becomes 21, 2 and 10. That's how it becomes 4, 2, 0. Hence, 420 silver coins must be melted to form a cuboid. So now let's check. Yes, option A is the correct answer here. 420 coins must be melted to form a cuboid. In question number 13, it is given that a tube is in the shape of a first drum of a cone. The radius of two circular ends of the tube are 105 centimeter and 42 centimeter. If the vertical height of the tube is 16 centimeter, what is its slant height? I have already given a diagram, already drawn a diagram here. R1 is the radius of the top circular ends and R2 is the radius of the lower circular ends. Okay. Here AB is the perpendicular, that is the vertical height between these two ends. So here we can say R1 is equals to, if it's OB, so we can easily find the value for BC. So here given the dimension of the first drum, that is R1, top circular end, radius of top circular end is 42 centimeter, R2, radius of lower circular end, that is 105 centimeter, and vertical height, that is AB, vertical height, that is 16 centimeter. We are here required to find the slant side. Let's say L, the length of the slant side L. So in triangle ABC, okay, it is a right angle triangle, so it will satisfy Pythagoras theorem, right? So how to find the value for AC square? Can find AB square plus BC square. Now BC square value will give us R2. I mean the OC equals to R2 here, R2, and let's say here P, this point. So PA equals to R1. So BC equals to here R2 minus R1, right? So R2 minus R1 whole square. Let's put all the values. L square equals to AB 16 whole square plus 105 minus 42 whole square. That will give us 56 plus 63 whole square. 6 plus 3, 969, 4225 L square. So here, if we find square root of 4225, we will get 65 centimeter. Hence, the slant side is 65 centimeter. Here, option B is the correct answer. In question number 14, it is given that ABC is a triangle right angled at B with AB equals to 8 centimeter and BC equals to 6 centimeter. it is made to revolve about its side BC, this side, perpendicular side. What is the approximate total surface area of the cone thus formed? Okay, so look, this is the right angle triangle, right angle at B, right? Now, when we make a cone, I mean, revolve to about its side BC, how it look like? Look, if we take it as the axis and if we rotate the side AB to as in a 360-degree angle, so then we can see there will be another portion of like this. Okay, it will looks like this. If I draw it, it will looks like this, where this is A, B, C. Okay, it will looks like this. Now here it is already given BC equals to 6 centimeter, AB 8 centimeter. We don't know the value for hypotenuse. Let's say that is L, or the slant side of the cone. So here, what will happen when we would revolve it? When the triangle is revolved about its side BC, the height of the cone will be the height and perpendicular height of the triangle, that is H is 6 centimeter. Okay, the radius of the cone thus formed R, that is the base length of the triangle. So R equals to 8 centimeter. So let's first find here the value for L with the help of the Pythagoras theorem. So in triangle ABC, we can use AC square equals to AB square plus BC square. Therefore, AC equals to root under 8 whole square plus 6 whole square. 36, so 10 centimeter. 10 centimeter. Okay. Now, we are here required to find total surface area of the cone formed. Okay, so total surface area of a cone. Let's write the formula first. Here total surface area means the curved surface area plus base, area of base. So formula for curved surface area pi RL, and since the base is of circular shape, so the area will be pi r square. Let's name it equation number 1. Okay. So putting R equals to 8 and L equals to 10 in 1, we get total surface area pi R L plus pi R square. So it will become, we can take common here, pi R 10 plus 8, 22 by 7, 8 multiplied by 18. This will give us the value 3168 by 7. Now we can, since it won't be completely divisible, we will get a quotient in decimal expression. So we can find, round it off, and we'll get the answer as 452 centimeter square. So hence the required approximate total surface area of the cone that is formed, that is 452 centimeter square. Here option A is the correct answer. Look at the solution again. In question number 15, it states that a solid rod consists of a cylinder of height 20 centimeter and radius 7 centimeter. It is surmounted by another solid cylinder of height 10 centimeter and radius 3.5 centimeter. If 1 cubic meter of rod weighs, okay, so here 10,000 kg, what is the mass of the rod? Okay, take pi equals to 22 by 7. Look, this I have already drawn the figure. There is a one big cylinder and one small cylinder. One is surmounted on another. Okay, so first for cylinder 1, let's name the bigger cylinder 1 and the smaller cylinder 2. So for cylinder 1, if I list down the dimensions of this, so here R1 7 centimeter, radius 7 centimeter and height 20 centimeter. Okay, whereas for cylinder 2, radius 3.5 centimeter and here height 10 centimeter. Now, what will be the volume of the solid, the complete solid? That is volume of the cylinder 1 and volume of cylinder 2. So volume of the solid rod, that is volume of cylinder 1 plus volume of cylinder 2. Okay, now what is the formula for finding volume? Pi R1 square H1 plus pi R2 square H2. Now we can put all the values here. After taking common pi, that is 22 by 7, 720 plus 3.5 multiplied by 10. Okay, so here now I can write 7 multiplied by 140 and 3.5 multiplied by 35 after finding the product of 3.5 and 10. From the both terms, I can take common 7. So it becomes 140 plus 17.5. 22 157.5, that will give us 3,465 centimeter cube. Okay, so here okay, now we will convert it into meter cube because 1 cubic meter of rods weight is been given, so we will convert it into meter cube now. So we know 1 centimeter equals to 1 by 100 meter. So since this is in centimeter cube, so we will divide it with 100 cube meter cube. Therefore, okay, so this is the volume, right? So therefore mass means weight, mass of rod, we are going to find the weight, mass of rod multiplied by kg, ten 10,000 kg. So we will write it as 34.65 kg. This is the answer. Hence, mass of the rod is 34.65 kg. So here, option A is the correct answer. In question number 16, it is given that what are distinct prime factors of the number 26,381? So here given number is 26,381. So we will find the factors by prime factorization. So look, first it will be divisible by 23. Can see 23, it would give us 1147. Further we can divide it by 31, that would give us 37. So look, we got 1. So here 26,381 can be represented as the product of 23, 31 and 37. And what is the definition of prime numbers? That is a number which is divisible by 1 and the number itself, that is called prime numbers. Okay, so here we won't conclude 1 because 1 is not a prime number, we already know that, whereas 23, 31, 37, these are the prime numbers. So hence we can say distinct prime factors In question number 17, it is given that which one of the following is a factor of the polynomial x minus 1, x minus 2, x minus 4, minus 90. So the polynomial represented by f of x, let's name it f of x, we can say x minus 1, x minus 2, x minus 4, minus 90. Okay, let's name it equation number, not equation, polynomial number 1. In the given options, the factors are x plus 14, x minus 14, x minus 6 and x minus 7, right? So by factors theorem, we know that x minus a is a factor of the polynomial f of x if f of a equals to 0. That's what factors theorem states. Now, if we consider the first option like x plus 14 and compare x plus 14 with x minus a, we can write as like x minus of minus 14. Correct. Now, if we compare with x minus a, then we can say that a equals to minus 14 here. Okay, so we have to check whether f of minus 14 will give us 0 or not. If it gives us 0, then we can say x plus 14 is a factor of this polynomial. Okay, so f of minus 14 will give us minus 1, minus 2, minus 4, minus 90. So as we can see, minus 15, minus 16, 18 and minus 19. So the final answer will be minus 4,410, which is not equals to 0. That means if x plus 14 is not a factor of this polynomial. Now let's check with x minus 14. If we consider it with x minus a, we can say a equals to 14, right? So here we are going to check with f of 14 now, whether it's 0 or not. So f of 14, 14 minus 1, 14 minus 2, 14 minus 4, minus 90. So now it is 13 and 12, 10, minus 90. Again, it is given us, that is 1,560 minus 90. Okay, no, it's not equals to 0. So it's not a factor. Let's next check with x minus 6 and x minus 7. These are two next of the factors. So if x minus 6 is a factor, if we compare with x minus a, then we can say equals to 6 here. So now let's find the value of f of 6. That will give us 6 minus 1, 6 minus 2, 6 minus 4 minus 90. So 4, 2, that is also 40 minus 90 not equals to 0. We are left with the last option, that is x minus 7. If we compare it with x minus a, we can say a equals to 7. Now let's find the value for f of 7. That is 7 minus 1, 7 minus 2, 7 minus 4, 90. So 6, 5, 3. Yes, now it is given us 90 minus 90, 0. So it's equals to 0. F of 7 given us the value 0. That's why we can say hence x minus 7 is a factor of given polynomial. Given polynomial. Okay. So yes, option D is the correct answer here. In question number 18, it states that what is the square root of 23 minus 4 root 15? Okay, now let's try to split it in the way 20 plus 3 minus 2 multiplied by, okay, so 2 multiplied by, let's say, root 3 and 2 root 5, okay, 2 root 5 and root 3. So, okay, now look here, 20 can be written as 2 root 5 whole square. If we, let's find the square of 2 root 5, 4 multiplied by 5, 20, correct? So 20 can be written as 2 root 5 whole square plus root 3 whole square will give us the value 3. That means 3 can be written as root 3 whole square, and already we have split it in this way. Now it looks like expansion formula of a minus b whole square, correct? Here, if we compare, here a is 2 root 5, b is root 3, correct? So we can write 2 root 5 minus root 3 whole square. Root 3 whole square. Also, since we have to match it with the option, so we can take root 3 in the first place. So it will look like root 3 minus 2 root 5 whole square. That will also give us the same thing. Root 3 minus 2 root 5 whole square, correct? Now look here, in this case, therefore, when we are going to find the square root of 23 minus 4 root 15, instead of 23 minus 4 root 15, we can write root 3 minus 2 root 5 whole square. So it will give us the value root 3 minus 2 root 5. That's the square root of 23 minus 4 root 15. So it matches with option C. In 19, it is given that what is the remainder after dividing the number 37 to the power 1000 by 9? So this given expression 37 to the power 1000 can be written as 37 to the power 1000 minus 1 plus 1. Further, 37 to the power 1000, and that 1 to the power anything will give us back 1, right? So 1 to the power 1000 plus 1. Now we know that x to the power n minus a to the power n is divisible by x minus A, correct? So therefore 37 to the power 1000 minus 1 to the power 1000 is divisible by x minus a. X is here 37 and a is here 1. So 37 minus 1, that is 36. The number is divisible by 36, correct? Also 36 is divisible by 9. We all know that. Therefore, it is divisible by 9, correct? So since 36, it is divisible by 36 and 36 is divisible by 9. So also this expression divisible by 9. But as we can see, we have splitted this expression into 37 whole to the power 1000 minus 1 plus 1. There is already one term already is there, that is 1. So that will be the remainder. When we divide, that portion will remain, that will be the remainder. So therefore 37 to the power 1000 minus 1 to the power 1000 is divisible by 9. Therefore required remainder 1. Okay, now let's check the options. Yes, option A is the correct answer here. In question number 20, it is given that the sum of LCM and HCF of the numbers is 536 and the difference between LCM and HCF is 296. If one of the numbers is 104, then what is the other number? So we can assume that let the LCM and HCF of two numbers be X and Y respectively. Okay, so according to the question, we can write the sum of them 536. Let's name it equation number 1, and the difference of LCM and HCF 296. Let's name it equation number 2. So after solving them in the method of elimination method, in the process of elimination method, what I will do, I will first add this to equation. Okay, if I add them, that will eliminate the variable y. So I will get 2, 3, 8. That means the value of x is 416. Now from equation 2, from not 2, let's put it 1. From 1, we can say y equals to 536 minus 416. That means y equals to 120 is the 120. Okay, so therefore it implies that LCM 416 and HCF 120. Okay, there is a relation between LCM, HCF and the numbers. That relation is product of LCM and HCF equals to product of two numbers. Product of two numbers. Okay, so we can assume let the other number be P. Okay, now therefore 416 multiplied by 120 equals to one number is given, that is 104. So 104 In question number 21, it is given that 20 men are supposed to complete a work in 10 days. After working for 5 days, they realize that only 1/4 of the work is done. How many more men they need to employ to finish the work on time? So we can assume let X more men are employed. X more men are employed. Okay, so here and there is one important formula that we are going to use in this question in order to solve it, that is mean multiplied with day by work equals to m2 multiplied with d2 w2. Here m denotes main number of person, d denotes days, and work denotes working amount of work that needs to be done. And how can we use the formula, how can we use all this data in this formula, that I'm going to show you in the next steps, in the next few steps. Okay, first of all, here they said only 1/4 of the work is done. So 20 men in the first case, we can see M1 20 men, and after working for 5 days, so they took 5 days to complete 1/4 of the work. Now, how much portion is remaining after completion of that 1/4? So that is, if we assume the whole part of the work is 1, so remaining portion of the work, remaining portion of the work, that is 3/4 part. Okay, so now we are going to find that, let's say x more men are employed. That means next case 20 plus x men are there. They will be taking like how many more okay, they will be taking, okay, they will be taking 5 days because it has to be finished within 10 days. So d2 5 days, and W2 equals to 3/4 part. That is the portion they have to complete. So now we are going to use the formula as 20 multiplied by 5 by 1/5, and 20 plus x multiplied by 5 by 3 by sorry, not 1/5, 1/4, and 3/4. Look, that was the formula. We have put all the values. Now let's solve it. 20 multiplied by 5 3/4, 5, 1/4. Both 5 got cancelled, 4 got cancelled. It becomes 60, 20 plus x. So we can say x equals to 40. So hence in question number 22, it is given that if x is a negative real number, then which of the following are not correct? There are 4 sentences given to you. There is a some natural number case such that kx greater than 0. So let's start with this statement. It's given that x is a negative number, right? X is a negative number. So here they are stating there is some natural number case such that kx greater than 0. So we know when a negative number is multiplied by a natural number, the resulting number will be negative. So a negative number is multiplied by a natural number k, then the resulting number will be negative. Okay, so in that case we can say kx greater than 0 is not correct, because kx will be also negative number, correct? Now let's check with second statement. X square plus 6 greater than 0. It is greater than 0 always. So now let's check with the example. Let's say for, so 1 done. Now for 2, second statement, for x equals to half, minus half. Okay, negative real number. So let's take minus half. Now we can say x square plus x, that will be minus half whole square plus of minus half. That means 1 by 4 minus half. So it will give us a value minus 1 by 4, that is less than 0. So again, it's not also correct that x square plus 6 greater than equals to greater than 0. It's not correct. Therefore, x square plus x greater than 0 is not always correct. In some cases, this might be true, but not always. Not always correct. Next, let's check with third statement. So third statement states that 2x less than x less than minus x, correct? So we can also check it with an example. So 2x less than x less than minus x. Now this can be splitted into 2x less than x and x less than minus x, right? So look here, 2x, twice of a negative number, that is obviously less than the same negative number. Okay, it is correct. And also a positive number, I mean, here it's given negative number, it will be a negative number. X is a negative number, and this negative number having a negative sign, it will be a positive number. So obviously negative number is less than a positive number, correct? So okay, let me write it, minus x is positive because x is negative. Okay, so this is also true, this one is also true. Therefore, we can say 2x less than x less than minus x is always correct. Is always correct. Now it's time to check the fourth statement. X square is always a rational number. Okay, so let's check it. For fourth statement, we can assume x equals to minus 2 whole to the power 1 by 4. Okay, we are assuming this way. Then x square will be minus 2 1 by 4 whole square. That means it will be 2 to the power 1 by 2, correct? So it will give us root 2, which is an irrational number, correct? Root 2 is irrational. Root 2 is irrational. Therefore, we can say x square is always a rational number is not a correct statement. So x square is not always rational number. Not always a rational number, correct? So we can see that 4 is not correct, 3 is correct, 2 is not correct, 1 is not correct. So here select the correct using code, I mean the following which are not correct. So 1, 2, 4, option B is the correct answer here. In question number 23, it is given that What is the sum of the linear factors in x and y of the expression 2x squared plus xy minus 3y squared? So here 2x squared xy minus 3y squared, we have to factorize it to find the linear factors. So here we can see 2 multiplied by 3 will give us 6. Now we will find a pair of the factors of 6 such that their difference will give us 1. So there is only one such pair, 3 minus 2, that will give us 1. So now we can balance it such way 3xy minus 2xy minus 3y squared. 2x plus 3y minus y, 2x plus 3y. Okay, so that means we can write 2x plus 3y and x minus y. These are two linear factors. Okay, so we are asked to find the sum of these linear factors. Sum of linear factors. So 3x plus 2y. Okay, so sum of the linear factors is 3x plus 2y. Option C is the. In question number 24, it is given that which one of the following equations doesn't have any real roots. So before we start solving, let me give you a small conceptual description. That is, what is the general form of an quadratic equation? That is ax squared plus bx plus c equals to 0. To check the nature of the roots, we always examine its discriminant. Discriminant is that is defined by d, that is b squared minus 4ac. Now, if b squared minus 4ac greater than 0, then the roots will be real. If b squared minus 4ac equals to 0, then the roots will be equal. And if b squared minus 4ac less than 0, then there is no real roots. Or we can say no real roots, or we can say roots are imaginary. Okay, so in this question, this part is being given, that is, we have to check which equations doesn't have any real roots. So we will check whether the discriminant is less than 0 or not. Okay, so let's start with the first equation, that is 2x squared plus 16x plus 3 equals to 0. We can compare it with the general form. So we will get a2, b16 and c3. So b squared minus 4ac will give us 16 whole square minus 4ac, 256 minus 24, 232. That is greater than 0. So roots are equal. It's not the answer. Next, for next quadratic equation, 2x squared plus 10x minus 1 equals to 0. Let's compare with general form. We will get a2, b10 and c minus 1. So the value of discriminant is 2 minus 1, 100 plus 8. Again, we are getting 108, that is greater than 0. So it will give us real root. Next, check quadratic equation. Third quadratic equation, x squared minus 8x plus 1 equals to 0. Here a1, b minus 8 and c 1. The value of discriminant will be minus 8 whole square minus 1 multiplied by 1. That means 64 minus 4 will give us 60 greater than 0. Only one quadratic equation left to examine, that is 4x squared plus 9x plus 6 equals to 0. Here a4, b9 and c6. So b squared minus 4ac will give us 9 whole square minus 4 multiplied by 4 multiplied by 6. So 81 by 96. It's Evidently that is less than 0, that is negative number, minus 15 less than 0. So this one is the quadratic equation that have no real roots. No real roots. So option D is the correct answer here. In question number 25, it is given that the sum and the product of the roots of a quadratic equation are 7 and 12 respectively. If the bigger root is halved and the smaller root is doubled, then what is the resulting quadratic equation? We can assume at the first place that the roots of the quadratic equation be A and B. Let the roots of the quadratic equation A and B. So it is being given that the sum of these two is 7 and the product of these two is 12. Let's name it equation number 1, equation number 2. So from 1, we can write B equals to 7 minus A, right? Now let's put the value of B in equation number 2. Therefore, we will get A multiplied of 7 minus A equals to 12. Now solve it. 7A minus C square, 12A square minus 7A plus 12. We will factorize it with the middle term method to get the factors. A square minus 4A minus 3A plus 12 as 4A minus 3 equals to 0. So either A equals to 4 or A equals to 3. Now when A equals to 3, the value of B is 7 minus 3, 4. Or when A equals to 4, value of B is 7 minus 4, 3. So you can see one root is 3, another root is 4. That is final. So here, smaller root is 3. Smaller root is 3 and bigger root is 4. Okay. Now, according to the question, the bigger root is halved and the smaller root is doubled. So make one half and another one is double. New roots are bigger root is half, so half of 4 and small double of the smaller root. 2 and 6. Now we know if we are given with the roots how to form the quadratic equation. So the formula is, let's say alpha and beta are roots. I'm giving you the conceptual description. If alpha and beta are the roots, so we can form the quadratic equation as x square minus alpha plus beta x plus alpha multiplied by beta equals to 0. So here let's say alpha equals to 2 and beta equals to 6. We will use this formula, x square minus 2 plus 6x plus 2 multiplied by 6, 0. X square minus 8x plus 12 equals to 0. So this is the quadratic equation, x square minus 8x plus 12 equals to 0. Option B is the correct answer. This is the required quadratic equation. In question number 26, it is given that for which values of k does the equation x square minus kx plus 2 equals to 0 have real and distinct solution? Given quadratic equation is x square minus kx plus 2 equals to 0. Okay. So first let's discuss about the concept, that is, we know the general form of an quadratic equation, that is ax square plus bx plus c equals to 0, right? And the nature of the roots depends on the sign of the discriminant right? So here discriminant is b square minus 4ac. Now if the discriminant greater than 0, so we can say equation will have real and distinct solution. Real and distinct solutions. Okay, so we will follow this method. So here, after comparing with the general form, the equation, we can say a1 b minus k and c 2. So the discriminant will be minus k whole square minus 4 multiplied by 1 multiplied by 2, that is k square minus 8. Now for which value of k this will have real and distinct solution? That means k square minus 8 has to be greater than 0. So let's make it greater than 0. K whole square minus 2 root 2 whole square greater than 0, or implies that k plus root 2 root 2 multiplied by k minus 2 root 2 greater than 0. We have used here the formula a square minus b square equals to a plus b, a minus b, correct? Now we can see the product of these two is greater than 0. That means they will be of same sign. Either they both are positive or they both are negative. So let's assume they both are positive. That means k plus 2 root 2 greater than 0 and k minus 2 root 2 greater than 0. So this will give us k greater than minus 2 root 2, k greater than 2 root 2. Obviously, if k greater than 2 root 2, that will be greater than of any negative number. So from here we can finally take that k greater than 2 root 2. Now if they both are of negative sign, k minus 2 root 2 less than 0, that means k less than minus 2 root 2 and k less than 2 root 2. So if k is less than negative 2 root 2, then obviously it is a negative number and that is less than for from any positive number. So from here the final value we will take in k less than minus 2 root 2. So either this case will be true or this case will be true. So we can say therefore k less than minus 2 root 2 or k greater than 2 root 2. If this happens, then the quadratic equation will have real and distinct solutions. So here we can see option D is the correct answer. K less than minus 2 root 2 or k greater than 2 root 2. In question number 27, it is given that if alpha plus beta plus gamma equals to the sum of the product of alpha beta and beta gamma and gamma alpha, then what is the value of 1 minus alpha multiplied by 1 minus beta multiplied by 1 minus gamma? So let's first write it down, all the given information: alpha plus beta plus gamma, alpha beta plus beta gamma plus gamma alpha. We can take them in one side and make it 0 the other side. So it will be alpha beta minus of gamma equals to 0. Now let's name it equation number 1. Write it down what we are required to find the value for. So here, after taking break it down, we will be getting 1 minus beta minus gamma alpha beta 1 minus alpha. Next it will be 1 minus alpha minus beta first square alpha square In question number 27, it is given that if the sum of alpha, beta, gamma is equal to the sum of alpha, beta, beta, gamma, and gamma, alpha, then what is the value of the product of 1 minus alpha, 1 minus beta, and 1 minus gamma? First, we will write the given information. Alpha plus beta plus gamma equals to alpha, beta, beta, gamma plus gamma delta. After putting all of them in one side, we will get 0. Let's name it equation number 1. Now write the given expression that we are required to find the value. First, we will find the product of first two terms. So 1 minus beta minus alpha minus plus alpha beta, 1 minus gamma. It becomes 1 minus gamma minus beta plus beta gamma minus alpha plus alpha gamma plus alpha beta minus alpha beta gamma. Now we can take common, not common, we can put in group like 1 minus, okay, first of all 1 plus alpha beta, beta gamma plus alpha gamma. Next, after taking common, minus alpha plus beta plus gamma, let's put a bracket, and minus alpha beta gamma. So from 1 we know this expression will give us 0, beta from 1. So the 1 minus alpha beta gamma, this is the value for the required expression. So here option A is the correct answer. In question number 28, it is given that if log x to the base 10 log x squared to the base 10 equals to 2 log x to the base 10 plus 1, then what is the value of x? We know log x squared will give us 2 log x, okay? And also, if we write log a to the base b equals to 1, that means we can write b to the power 1 equals to a. This is comes from the very basic fundamental concept of logarithm. So let me write the given expression. Log x squared 10 to log x to the base 10 plus 1. Now we know log x to the base 10 plus 2 log x to the base 10, 2 log x to the base 10 plus 1. So both will got cancelled. Here log x to the base 10 equals to 1. From 1, let's name it 1 and 2. So from 2 we can write x equals to 10 to the power 1. That means x equals to 10. So here, and it comes from second law 2. So the value of x is 10. Option D is the correct answer. In question number 29, it states that the LCM of two prime numbers P and Q is 2231, where P greater than Q. What is the value of P minus Q? So we know there is a relation between LCM and the product of the numbers. Since these are two prime numbers, so LCM of two prime numbers, that will be equal to the product of the numbers. Okay, so here 2231 equals to P multiplied by Q. So how many possible options are there for the value of P and Q? We can write like P multiplied by Q can be represented as 23 multiplied by 97, because these two are prime numbers and the product of them will give us 2231. So therefore P equals to 97 and Q equals to 23, because it is given P greater than Q. Okay, so now let's find the difference. Now P minus Q will be 97 minus 23, that is 74. Hence the value of P minus Q is 74. Option C is the correct answer. In question number 30, it is given that 3 runners are running in a circular track and they complete one round in 20, 30 and 35 minutes respectively. When will they next meet at the starting point? So the time interval when they will meet next at the starting point that is LCM of 20, 30 and 35 minutes. So we will find the prime factorization of 20, 30 and 35. So 22 multiplied by 2 multiplied by 5, next 30, 20, 3, 5 and 35, that is 5 multiplied by 7. So therefore LCM 2 square, 3, 5 and 7. So we can write 12, 35, that will be 420 minute. So we can convert it into hour and minute both. So that is 7 hour. After dividing 420 by 60, we will get 7 hour. Okay, so hence all 3 runners will meet after 7 hour at the. In question number 31, it states that what is the minimum value of cos cube theta plus 6 cube theta, where theta lies between 0 degree to 90 degree. We know 0 degree to 90 degree means it refers the first quadrant. We know in first quadrant all are positive. So obviously in this quadrant cos theta and sec theta both are positive. In the interval 0 degree theta to 90 degree, cos theta and sec theta are positive. Okay, now we will use one more concept. Let me say A, B. If we try to find the arithmetic mean and geometric mean of this two, so and we already know arithmetic mean is greater than equals to geometric mean. How can we find arithmetic mean? A plus B by 2 greater than equals to root under AB. That is the relation. Okay, so on applying AM-GM relation on cos cube theta and sec cube theta, we get cos cube theta plus sec cube theta by 2 greater than equals to root under cos cube theta sec cube theta. So here we can see since cos theta equals to 1 by sec theta, they are reciprocal, correct? So cos cube theta plus sec cube theta, this will give us 2 multiplied by 1. So we can see the sum of cos cube theta and sec cube theta will be more than 2, will be equal or more than 2. So the minimum value of cos cube theta plus sec cube theta is 2. So here option C is the correct answer. Minimum value of cos cube theta plus sec cube theta, that is 2. In question number 32, it states that if 14 sine squared theta plus 10 cos squared theta equals to 11, then where theta lies between 0 degree to 90 degree, then what is the value of tan theta plus cot theta? So it's given 14 sine squared theta plus 10 cos squared theta equals to 11. We know that sine squared theta plus cos squared theta equals to 1. We will use this relation. So let's break it. 4 sine squared theta plus 10 sine squared theta. Already 10 cos squared theta is there. Now after taking 10 common, we will have sine squared theta plus cos squared theta equals to 11. So 4 sine squared theta. Now this will give us 1. That means it will become 4 sine squared theta plus 10 multiplied by 1 equals to 11. So we can see the value of sine square theta, 11 minus 10, 1 by 4. So sine theta will give us plus minus half. Now look at the question. It's given that theta lies between 0 degree to 90 degree. That means first quadrant. As I have already said that all are positive in first quadrant. So sine theta cannot be negative in first quadrant. Sine theta cannot be negative in first quadrant, right? So we will take sine theta as plus half. Now remember in which angle sine give us the value half? 30 degree. So sine theta equals to sine 30 degree, where theta equals to 30 degree. Now we will put this value of theta in tan theta and cot theta, right? So tan 30 degree plus cot 30 degree. This will give us 1 by root 2 and 1 by root 3, and cot 30 degree will give us root 3. So 1 plus 3, 4 by root 3 is the answer. Let's check it. Yes, option A, 4 by root 3 is the correct answer. In question number 33, it is given that what is the value of this given expression? Let me first write it down. Sine cube theta plus cos cube theta by sine theta plus cos theta, sine cube theta minus cos cube theta by sine theta minus cos theta. First, let me make you remember few important algebraic formulas. Those are a cube plus b cube will give us a plus b, a square minus ab plus b square. Also, a cube minus b cube, a minus b, a square plus ab plus b square. Okay. Now let's use all this formula here. So compare sine, consider sine theta as a and cos theta as b. So this will give us sine theta plus cos theta sine squared theta minus sine theta cos theta plus cos square theta theta. Now for the second term, I will write downside. So sine theta minus cos theta. It will become sine squared theta plus sine theta cos theta plus cos square theta by sine theta minus cos theta, right? Let's put them in bracket. So this will got cancelled in both term. Now sine square theta plus cos square theta, since sine square theta plus cos square theta equals to 1. So we can put 1 minus sine theta cos theta plus again 1 plus sine theta cos theta. So both will got cancel. We are left with 2. 1 plus 1, 2. Here option C is the correct answer, 2. In question number 34, it is given that a ladder 10 meter long reaches a point 10 meter below the top of a vertical flagstaff. From the foot of the ladder, the elevation of the top of the flagstaff is 60 degree. Then what is the height of the flagstaff? So as we can see here, OQ, this is the ladder. Let OQ be a ladder. I have already done with the drawing. Therefore, we know a ladder 10 meter long. So OQ 10 meter. Next, some part of flagstaff, that is QR, that is 10 meter, because it's been given ladder reaches a point 10 meter below the top of a vertical flagstaff. So QR 10 meter. We don't know the height of the top of the flagstaff from the ground. So we can assume that PQ, let PQ H meter. Okay. So in triangle OPR, it's given that this one is 60 degree, angle POR, that is 60 degree, because it's being given from the foot of the ladder. This is the foot of the ladder at the point 2. The elevation of the top of the flagstaff, that is 60 degree. And since it is a right angle triangle, angle B is 90 degree. Therefore, we can write angle R is 30 degree. Since we can see, since QR and OQ both are same, both are equal, both are 10 centimeter. So we can write that ORQ, ROQ, these two are equal. ORQ and ROQ, these two are equal. So they will be, both of this will be 30 degree. Let me write here 30 degree. Next, so here we can write tan 60 degree, that is RP or PR by PO. That means root 3 PR 10 plus H by OP. We don't know the value for OP. Now let's name it. Okay, so OP can be written as 10 plus H by root 3. Let's name it equation number 1. Next, tan 30 degree, H by OP. So 1 by root 3 H by OP, or OP can be written as root 3H. Let's name it equation number 2. Now from 1 and 2, Both are giving us the value of OP. We can make them equal. Root 3h or 10 plus h equals to 3h. So 2h10, h equals to 5 meter. So the height of the flagstaff, flagstaff, that is h plus 10. In question number 35, it is given that what is the maximum value of 1 plus 2 sine square theta cos square theta minus sine to the power 4 theta minus cos to the power 4 theta, where theta lies between 0 degree to 90 degree. So let me first try to simplify the given expression. 1 plus 2 sine square theta cos square theta minus sine to the power 4 theta minus cos to the power 4 theta. So after making a group of them, we can take common minus. So it will be sine to the power 4 theta plus cos to the power 4 theta minus 2 sine square theta cos square theta. So if we try to split it, like sine square theta whole square plus cos square theta whole square minus 2 sine square theta cos square theta. So it looks like a square plus b square minus 2ab. That will give us a minus b whole square. So here we will compare sine square theta as a and cos square theta as b. We'll be getting cos, or we can consider cos square theta as a and sine square theta as b. So we can write cos square theta minus sine square theta whole square. Also, there is a formula that cos 2 theta equals to cos square theta minus sine square theta. So this means it will give us cos square 2 theta. Okay. So 1 minus cos square 2 theta will give us sine square 2 theta, right? So here, what is the maximum value they have asked us, right? So we know the maximum value for sine theta, that is 1. Okay, this is coming from since sine square theta plus cos square theta, that is 1. For maximum value sine square theta equals to 1. So sine 2 theta is 1. We can write sine 2 theta sine 90 degree. 1 will give us at the angle 90 degree. That means theta is 45 degree. Therefore, maximum value will be at 45 degrees. So 1 plus 2 sine square 45 degree cos square 45 degree minus sine to the power 4 45 degree cos to the power 4 45 degree half, because we know sine 45 degree will give us the value 1 by root 2. So it will be half. Same cos 45 degree will give us 1 by root 2. It's same also half minus 1 by 4 minus 1 by 4. So 1 plus half minus half. That means both will got cancelled. So we will get 1. So the maximum value of the given expression is 1. Option A is the correct answer. In question number 36, it is given that from an aeroplane flying above a river at an altitude of 1200 meter, it is observed that the angles of depression of opposite points on the two banks of a river are 30° and theta. If the width of the river is 3000 meter, then which one of the following is correct? I have already done with the construction diagram of the above scenario. So here AD is the altitude of the flying aeroplane and BC is the width of the river, that is 3000 meter. So since AD is the altitude, so AD will be 1200 meter. So given altitude of aeroplane is given 1200 meter and the width of the river 3000 meter. So in triangle ABD, we have that angle of depression of one bank is 30°. Okay, so tan 30° perpendicular by base, that is AD by BD. Tan 30° will give us 1 by root 3, 1200 by BD. So the value of BD 1200 root 3. Okay. Next, therefore, we can find the value of DC, that is BC minus BD. So the value of BC 3000 minus 1200 root 3. Next, in ACD, in this right angle triangle, in ACD, we can write AD by DC tan theta, correct? Or we can write DC by AD, that is cot theta, just the reciprocal. So DC is 3000 minus 1200 root 3 by 1200. So here it is equals to cot theta. Now let's try to simplify it. So after taking 100 common, it will become 30 minus 12 root 3 by 12, or cot theta. We can take common 6. So it will be 5 minus 2 root 3 by 2. So that will give us value. We know that we also can write the value of root 3, that is 1.732. So here 1.732. So after doing this calculation, that is 5 minus 2 multiplied by 1.732 divided by another 2, we will get 0.77 approx, after doing rounding off and all things. And we know cot theta is a decreasing function in the first quadrant, Okay, so and cot 45° will give us value 1, whereas cot 60° will give us 1 by root 3. That is 1 by root 3 near about 0.6. So we can see cot 45° is greater than cot theta, that is greater than cot 60°. So here we can say that which one of the following is correct. So option, so theta will lies between 45° and 60°, correct? So here option C is the correct one. Theta will lie between 45 degree to 60 degree. Option C is the correct answer here. In question number 37, it is given that if cos square theta minus 3 cos theta plus 2 by sine square theta equals to 1, where theta lies between 0 degree to 90 degree, then what is sine square theta plus cos theta equals to? First, from the given equation, we will try to find out the value for theta. So here, cos theta minus 3 cos theta plus 2 by sine square theta equals to 1. That will give us cos square theta 3 cos theta plus 2 sine square theta. So we can also write in this case, since we know cos theta minus 3 cos theta plus 2 sine square in terms of cos theta, that is 1 minus cos square theta, because we know sine square theta plus cos square theta, that will give us 1. So here 2 cos square theta minus 3 cos theta plus 1 equals to 0. After doing the middle term, or 2 cos theta minus 1 and another cos theta minus 1. So the factors will be cos theta minus 1, 2 cos theta minus 1. That is either cos theta minus 1, 0, or 2 cos theta minus 1, 0. That means cos theta equals to 1. Cos theta half. So in the given interval, so here and also in the given interval, theta is not equals to 0, because theta that is greater than 0. So we cannot take 1, since theta not equals to 0. Therefore, we will only consider this case, cos theta equals to half. We will get the value for sine theta from it, 1 minus half whole square. It's coming from this formula, sine theta equals to root under 1 minus cos square theta. So it will be result in root 3 by 2 sine theta. Therefore, sine square theta plus cos theta root 3 by 2 whole square plus half 3 by 4 plus half, that means 3 by 4 plus 2 by 4. So 5 by 4 is the answer. Here option A is the correct answer. Sine square theta plus cos theta equal to 5 by 4. In question number 38, it is given that consider the following. There are 3 different statements rather than identities. Which of the above identities are true? Which of the above statements are true? We have to check that. The first one is first statement, LHS. In LHS, it's given sine to the power 4 theta minus sine square theta. After taking sine square theta common, we can write here sine square theta minus 1. We'll be getting sine square theta minus cos square theta, because we know sine square theta plus cos square theta will give us 1. So minus sine square theta cos square theta. This is the expression. Now let's calculate RHS, that is cos to the power 4 theta minus cos square theta. After taking cos square theta common, it become cos square theta minus 1. Again, with help of this identity, we can write it's minus sine square theta. So that means minus sine square theta cos square theta. So here we can see LHS equals to RHS. That means this statement identities are true. Next, in the next statement, we can see sine to the power 4 theta plus cos to the power 4 theta. So LHS sine to the power 4 theta plus cos to the power 4 theta. We can consider it sine square theta whole square plus cos square theta whole square. So sine square theta plus cos square theta whole square minus 2 sine square theta cos square theta. 1 minus sine square theta cos square theta. Now let's check RHS. RHS is given as 1 plus 2 sine square theta plus cos square theta. 2 sine square theta cos square theta. So we can see LHS and RHS, they are not same. They are not equal. So this is not true. Now let's check for third identity. Third identity is given as tan to the power 4 theta plus tan square theta. So tan to the power 4 theta plus tan square theta. We can take tan square theta common. It will become tan square theta plus 1. Since we know 1 plus tan square theta will give us 6 square theta. Tan square theta multiplied by 6 square theta. So here next 6 to the power 4 theta minus 6 square theta. Okay, this one is coming from LHS. Now let's write RHS. 6 to the power 4 theta minus 6 square theta. So after taking 6 square theta common, 6 square theta minus 1. So that is also give us from these identities tan square theta. So we can see both are giving us tan square theta, 6 square theta. Therefore, LHS equals to RHS. So third identities is also true. So which of the above are identities? So we have seen only second statement is wrong. Other than 1 and 3 are true. That means 1 and 3 are. In question number 39, it is given that what is the value of sine 24 degree, sine 60 degree minus cos 24 degree, cos 66 degree plus tan 24 degree, tan 66 degree minus cot 24 degree, cot 66 degree. Let me first write the expression. 24 degree cos 66 degree plus tan 24 degree tan 66 degree minus cot 24 degree cot 66 degree. Here we can see the sum of 24 and 66 will give us 90. That means they are complementary angle. So we can write sine 90 degree minus 66 degree. We can change this sign. 90 degree minus 24 degree will keep cos 24 degree cos 66 degree as it is. Next, tan 90 degree minus 60 degree 66 degree and tan 90 degree minus 24 degree will keep cot as it is 66 degree. Next, we know that sine 90 degree minus theta will give us cos theta. So it becomes cos 66 degree, cos 24 degree, cos 24 degree, cos 66 degree plus also tan 90 degree minus theta, that is cot theta. So here cot 66 degree cot 24 degree minus cot 24 degree cot 66 degree. So all these terms will got cancelled. We will left with only 0. Here option A is the correct answer. In question number 40, it is given that if x equals to p sine a cos b, y equals to p sine a sine b, and z equals to p cos a, then what is the value of x square plus y square plus z square? First, list up all the given information. X, p sine a cos b, y equals to p sine a sine b, and z equals to p cos a. So here x square plus y square plus z square will give us cos b whole square plus p sine a sine b whole square plus p cos a whole square. So we can take p square common from all the terms. So it will be sine square a cos square b plus sine square a sine square b plus cos square a. Next, from first two terms we can take common sine square a. So it will be cos square b plus sine square b plus cos square a. So we know cos square b and sine square b, the sum of them is 1. Sine square theta plus cos square theta equals to 1. So that means again sine square plus cos square will give us value 1. So here p square is the final answer. Option C is the correct answer here. In question number 41, it is given that if x equals to m sec a plus n tan a and y equals to m tan a plus n sec a, then what is the value of x square minus y square? First, we will list down all the given informations. That is x equals to m sec a plus n tan a, and also y equals to m tan a plus n sec a. Okay, now let's put all those value in the given expression, that is x square minus y square, and start solving step by step. Whole square minus m tan a plus n sec a whole square. We will expand it with the help of the formula a plus b whole square, a square plus b square plus 2ab. Okay, so it will become m square sec square a plus n square tan square a plus 2mn tan a sec a minus m square tan square m square tan square a minus n square sec square a minus 2mn tan a sec a. Okay, now we can take common m square from these two terms. It will become sec square a minus tan square a plus next plus n square tan square a minus sec square a, and both 2mn tan a sec a will got cancelled. So here we know sec square theta minus tan square theta will give us value 1. So it becomes m square multiplied by 1. Since it is tan square a minus sec square a, so we will write it as minus n. So n square minus minus 1. So n square minus 1, it will become m square minus n square. This is the final result. So it matches with. In question number 42, it is given that if for some theta lying between 0 degree and 90 degree, tan theta equals to 1, then what is the value of sine square theta minus 2 sine theta cos theta? First of all, it's given that tan theta equals to 1. We have to remember that in which angle, in which acute angle theta gives us value 1, that is 45 degree. Also, it is given that theta lies between 0 degree to 90 degree. So we can write tan theta equals to tan 45 degree. So theta equals to 45 degree, right? Now let's check the given expression, sine square theta to sine theta cos theta. Sine square theta minus 2 sine theta cos theta. So let's put the value. Put theta equals to 45 degree. Sine 45 degree to sine 45 degree cos 45 degree. Now we know sine 45 degree gives us value 1 by root 2. Cos 45 degree also give us the same value 1 by root 2. So 1 by root 2 whole square minus 2 multiplied by 1 by root 2, 1 by root 2. So half minus 1, it will be result in minus half. So here option D is the correct answer. In question number 43, it is given that what is 2 sine cube theta minus sine theta by cos theta minus 2 cos cube theta? We have to simplify the given expression. So 2 sine cube theta minus sine theta by cos theta minus 2 cos cube theta. We can take sine theta common. It becomes 2 sine squared theta minus 1 by, after taking cos theta common, 1 minus 2 cos square theta. Okay. Now we know that there is a formula cos 2a equals to, or we can write two cos square a minus 1. Okay. Also we can write 1 minus cos 2a equals to 2 sine square a. These are two formula we are going to implant here. So look, it becomes 1 minus 2 sine square a, that is cos 2a. So it will give us sine theta minus cos 2 theta, because 2 sine square a, from here we can write 2 sine square a minus 1 will give us minus cos 2a. Minus cos 2a by cos theta. So 1 minus 2 cos square theta will give us another minus cos 2a. That is minus cos 2 theta. Both minus cos 2 theta got cancelled. We will get tan theta. So here tan theta is the answer. If we simplify the given expression, we will get tan theta. Option C is the correct answer here. In question number 44, it is given that if A, B, and C are interior angles of triangle ABC, then what is tan of B plus C by 2 plus sine of B plus C by 2 minus cot of A by 2 minus cos of A by 2 equal to? So let me first write the given expression, that is tan of B plus C by 2 plus sine of B plus C by 2 minus cot A by 2 minus cos A by 2. Okay. Okay. So we also know, that the sum of all three interior angles of a triangle is 180 degrees. So from here we can say angle A plus angle B plus angle C equals to 180 degree. That means B plus C can be written as 180 degree minus A. Okay. Also, okay, so let me again write the given expression, that is tan of B plus C by 2 sine B plus C by 2 minus cot A by 2 minus cos A by 2. So in place of B plus C, we can write 180 degree minus A, tan 180 degree minus A by 2 plus sine 180 degree minus A by 2 minus cot A by 2 minus cos A by 2. So here Further, we can write 90 degree minus a by 2. Same sine 90 degree minus a by 2 minus cot a by 2 minus cos a by 2. So here we will use the concept of complementary angle. That is, we know tan 90 degree minus theta, that is cot theta. Also sine 90 degree minus theta, that is cos theta. So in place of theta it is given a by 2. We can write cot a by 2 plus cos a by 2 minus cot a by 2 minus cos a by 2. Both cot and cos will got cancelled. We will left with only 0. So the given expression results in 0. Here option A is the correct answer. In question number 45, it is given that in a triangle ABC, right angled at B, and the sum of AB and BC, that is tan of 1 plus root 3 centimeter length of the hypotenuse is 20 centimeter. What is the value of tan A and tan C? Sum of tan A and tan C. So this is right angle triangle, this ABC, and it is given that sum of the base and the perpendicular tan of 1 plus root 3. Also B is 90 degree and the hypotenuse, that is 20 centimeter. So since ABC is right angle triangle, we can use Pythagoras theorem. So by Pythagoras, we can write AB square plus BC square equals to AC square. Also 20 whole square, that means AB square plus BC square, that is 400. Let's name it equation number 1. Also, now AB plus BC, that is tan of 1 plus root 2. Let's do square both the side. Squaring both the side, we get A plus AB plus BC whole square and tan of 1 plus root 3 whole square. Now expand it with the help of A plus B whole square. The formula is A square plus B square plus 2AB. So AB square plus BC square plus 2 of AB BC, and it will be 100, 1 plus 3 plus 2 root 3. Also, we can write in place of AB and AB square and BC square 400 from 1. 400 plus 2 AB multiplied by BC, that is 100 plus 300 plus 200 root 3. So both 400 will got cancelled, and we can write the product of AB and BC 200 root 3 by 2. So it will result in 100 root 3. Okay, now let's name it equation number 2. Now we are going to write tan A plus tan C. So now tan A plus tan C. So according to the triangle, tan is BC by BA, BC by BA or AB, and tan C is AB by BC, AB by BC. Let's do the LCM. It will be BC square plus AB square. That means 400 by 100 root 3. So 4 by root 3 is the answer. It matches with option A. Option A is the correct answer here. In question number 46, it is given that a solid consisting of a right circular cone of radius x and height 2x standing on a hemisphere of radius x. The volume of the solid is equal to that of a, okay, so here we are going to find the volume of a solid. First of all, we have to consider this question for the next three following questions also, starting from this 46 one. So here, the solid is a combination of right circular cone and hemisphere. We know that for right circular cone, if R1 is the base, the radius of the base, and H1 is the height, so we can say volume is 1/3 pi R1 square H1. And for hemisphere, if R2 the base, in case of hemisphere, radius R2 is the radius of the base. In case of hemisphere, radius and height is same, equal. So R2 is the radius. We can say volume is 2/3 pi R cube. That is R2 cube, right? So here we are given that R1 and R2 both are same, R1 and R2, that is x, because here we can say that the base of the cone is the base of the hemisphere also, and H1, that is 2x. Okay, so volume of the solid, therefore volume of the solid, that is volume of the cone plus volume of hemisphere. The sum of the volume of cone and hemisphere is the volume of the solid. Okay, so here let's put all those values. So 1/3 pi x square multiplied by 2x plus 2/3 pi x cube. We can take 1/3 pi common. It will become 2x cube plus 2x cube. That means 4x cube pi by 3. So in place of pi, we can put 22 by 7 also. First, let's check that in options it's given that it is equal to sphere of radius x, sphere of diameter x, cylinder of radius x, and cylinder of radius 2x. Now, first of all, if there is a sphere, what is the volume of a sphere? So volume of a sphere, if its radius is x, radius is x, that means we can write 4/3 pi x cube. Okay, volume of a sphere. So we can see that these two matches, 4/3 pi x cube. So we can say that the volume of the solid is equal to that of a sphere of radius x. Option A is the correct answer. In this question, we are asked to find the approximate total surface area of the solid. So here we are already given that we have for cone R is x and H is 2x. Let's name it AOB. So here AB is the slant slide. We can denote it as L. For hemisphere, the radius of the base is x also. So we know the formula of the total surface area of the solid. Total surface area of the solid, that is total surface area of cone plus curved surface area of cone and curved surface area of hemisphere. Curved surface area of cone plus area of hemisphere. And the formula of curved surface area of a cone is pi RL, where R is the radius of the base and L is the length of the side, and curved surface area of the hemisphere, that is 2 pi R square. Okay, 2 pi R square. So we will put all the four values, but before that we will try to find here the value of L. So in right angle triangle ABC, this is right angle triangle because angle O is 90 degree. We can write OA square plus OB square. OA square plus OB square, that is AB square. So here OA means the height, that is 2x whole square plus x whole square and AB square. So we can easily write AB equals to root under 4x square plus x square. So here root 5x. Let's name it equation number 1. No, it's equation number 2 and this one is equation number 1. Now put AB equals to root 5x in equation number 1. So total surface area of the solid, that is pi RL. Okay, also we can use the value of pi, that is 3.14. After rounding off, we can write 3.14. So pi RL root 5x plus 2 pi x square. 2 pi x square. So here 3.14 multiplied by root 5. After rounding it off, we can write the value of root 5 as 2.23 multiplied by x square. And here 2 multiplied by 3.14 multiplied by x square. So that will give us 7.002 x square here and 6.28 x square. That means it will result in 13.2822 x square. Approximately we can write 13.3 x square. So here the approximate total surface area of the solid is 13.3 x square. Option C is the correct answer. Let's have a look on the solution again. In question number 48, it is given that the solid is placed the upright in a right circular cylinder full of water such that it touches the bottom. If the internal radius of the cylinder is x and height is 3x, what is the approximate value of water left in the cylinder? So we are given the dimensions as follows. First, let me list down all the given informations. For cone, the radius is x and height is 2x. Now for hemisphere, radius is x and radius and height both are same for hemisphere. Now for cylinder, radius is x and height is x plus 2x. So it becomes 3x. Now when the solid is placed into the cylinder, the water equal to the volume of the solid will be overflowed or emptied. So when the solid is placed into the cylinder, then the water equal to the volume of solid will be emptied, right? So that will be overflowed or emptied. Now, hence the water left in the cylinder, hence the water left in the cylinder, that is the total volume of the cylinder and the difference of volume of the cylinder and volume of the solid. So volume of cylinder minus volume of solid. The formula for finding volume of cylinder is pi r square h. Pi, here r is r cube, r square h cube, minus volume of the solid is, we have already found it out that what is the volume of the solid, that is equal to a sphere of radius 6, so 4/3 pi x cube, 4/3 pi x cube. It is obtained in question number 46. Obtained in question number 46. Okay, remember that. Now we'll put all these things, that is x square 3x minus 4/3 pi x cube. So it will result in pi 3x cube minus 4/3 pi x cube. We will take common pi x cube, 3 minus 4/3. So pi x cube, that is 9 minus 4. So 5/3 pi x cube. Now we can use the value of pi, that is 3.14 x cube. We can see the value will be 15.7 x cube by 3. If we further divide it, 15.7 by 3, we will get 5.24 x cube. Hence, the approximate volume of the water that is left inside the cylinder, that is 5.24 x cube. So here 5.24 x cube, option D is the correct answer. Option D is the correct answer. This much amount of water. In question number 49, it is given that the chord of a circle of radius 2.1 centimeter is inclined the angle of 120 degree on the center of the circle. Also, it is given the value of pi 22/7 and √3 1.732. What is the approximate area of the minor segment of the circle? So what is minor segment? If I draw a circle and here AB is an chord. So this part, that the chord and the circle enclosed part, that is called, the small part is called minor segment and the larger part is called major segment. So here we can see AB, this part we are required to find the area of this part. So how can we find it? We have to first find the area of the minor sector. What is minor sector? Minor sector is the area that is enclosed by radius and arc, that is called minor, that is called sector. Okay, region enclosed by arc and its two bounding radius is called sector. So let me draw it. Let's say this is minor sector and this part is major sector. So here OAB is minor sector, and this the shaded part is minor segment. So here in the given question, radius of circle, that is 2.1 centimeter, and the central angle AOB, that is 120 degree. So here area of minor segment of the circle equals to area of minor sector minus area of triangle formed. Okay, so as we can see OAB, there is a triangle formed. Now area of minor sector, the formula is theta by 360 degree pi r square minus an area of the triangle formed, that formula is half r square sine theta. Basically the we can find the area of a triangle with the formula that half of AB sine theta. So here A and B both are referring the radius of the circle. So half r square sine theta. Now we will all put all the values here. So it becomes in the place of theta, we can write 120 degree, 360 degree, 22 by 7, 2 point r multiplied by 2 point r minus half 2.1 whole square sine 120 degree. So here 1/3, it becomes 1/3 multiplied by 22 by 7, 100 minus half, 100. Now sine 120 degree, there is a formula that is sine 2 theta can be written as 2 sine theta cos theta. I'm going to use that formula. 120 degree means 2 multiplied twice 60 degree. So it can be written as 2 sine 60 degree cos 60 degree. So here we can see 21 got cancelled. This 2 got cancelled. So we can take it as 22 multiplied by 21, 100 minus 21 multiplied by 21 by 100. 60 sine 60 degree will give us √3 by 2, cos 60 degree will give us half. So after taking common 100, it becomes 462 minus. Also the value of √3 is 1.732. Okay, so we will use all these things. 441 multiplied by 1.732 multiplied by 1 by 4. So it becomes 462 minus 1.732, 1 by 100, 462 minus 190.953. So here 271.047 by 100, approximately we can write 2.71 centimeter square. So here the approximate area of the minor segment of the circle, approximate area of the minor segment of the circle is 2.71 centimeter square. In question number 50, it is given that What is the approximate area of the major segment of the circle? It is the continuation of the previous sum, that the chord of a circle of radius 2.1 centimeter is inclined the angle of 120 degree on the center of the circle. So here I have already drawn the figure. So this part is called major segment part. How can we find the area of this part? The approximate area segment of circle, that is area of circle, and minus of area of minor segment. Minor segment. So in the previous question, we have already found the area of the minor segment, that is 2.71 centimeter square. So here the area is pi r square minus 2.71. This 2.71 already obtained in question number 49. Remember that. Now place all those values. 22 by 7, 271 by 100. So yes, we can take 100 common, and next it will be, we can multiply 22 multiplied by 3 multiplied by 21. We will get 1386 minus 271. So this will result in 1115 by 100. That means 11.15 centimeter is the answer. The approximate area of the major segment of the circle is 11.15 centimeter square. Here option D is the correct answer.